Good afternoon, everyone. Thanks so much, Jag, for the awesome presentation or the awesome introduction. So I'm going to be talking a little bit today about just my background and journey as a data scientist, informatician, and really where my journey is today. That's a little part of it. The more important part is about productioning and putting your machine learning analytics models in a more complete pipeline environment. I'm with a little-known company called Intel. I spend my time mostly designing in solutions for analytics, AI, visual compute systems for customers. But I'm going to walk you through a couple of, a little bit about my journey so that you get some context. And then I like to always start a presentation or a training with a quote, kind of pay homage to our predecessors. Just a little feedback. Is that okay? Yes? Okay, cool. So today I was inspired to actually talk a little bit about AI in the form of one of my favorite writers, Arthur Conan Doyle. He, of course, Sherlock Holmes, we know the character really well. Sherlock Holmes always talked about the role of data in coming up with decisioning and actually forming premature assumptions without adequate data is kind of the bane of our existence. So today, Intel wanted to take a couple seconds just to highlight what we're doing to get out of that preconceived notion of what a siloed view of data engineering and specifically data assets come from. So today we're announcing a project called Blue Danube. It's a joint partnership between us and Intel, H2O and Intel, on actually making production-grade AI workflows move across your entire infrastructure stack. So that's kind of where we're going to go today. Specifically with machine learning and machine learning algorithms, the way they behave across different compute environments plays a big role in how and where we source data, cleanse data, parse it, structure it, production it, and tune for it. So we're going to talk a little bit about that. Before all that, I'm going to talk a little bit about my journey and how I came here. As Jag was saying, I'm passionate about AI. I actually chose this profession more than 20 years ago when I was an undergrad, and I was working at that time in genetics. So in a preclinical trials facility, and we were getting ready for FDA submissions. This is late 90s, and the genome race was going on at that time. So the notion and the premise that you could model genetic behavior through mathematical systems and then use that to make informed decisions through what today we would call modern machine learning techniques. At that time, 20 years ago, we were using more traditional machine learning data science systems. In fact, when I was a graduate student, that'll give you guys a time marker on my age, we were using GANs and multi-attribute utility models interchangeably as nomenclature. So I see a few smiles here, so you'll get some context on that. But the point being is that AI is not a new field. Data science has been there for a while. I got into the profession of genetics because I had family that had medical challenges, and I'd worked in research with automation for disabled patients, stem cell research and things like that, and had learned that, oh, if we made better decisions and could simulate that behavior over a long period of time, we might have better products. So that started the journey. I think all of us started our journey in different instantiated ways and similar ways. Where I'm headed with all of this is that we're now starting to enter what I call the golden era of AI. And certainly for Intel and for all of us here in this community, this is a big part of where this journey is headed. Every day you're going to look around and see AI components or machine learning data science component in everything you do. And case in point, we had a speaker from Gartner earlier. And we'd conducted a study recently, and we found that about 46% of CIOs, so folks that are using, folks that are heading hospitals, banks, mining companies, energy companies, almost all of them want to implement AI. 46% of them have either developed plans or are in POCs, and then subsequent to that, only 4% are actually developing real AI systems that we would consider production. That means there's a tremendous amount of opportunity. I'm going to pause on this image for a second. Does anybody know what this is? What is it? It's a homunculus. Someone said homunculus. This is a neocortex map of the neuronal distribution. That means the sensing output that your neurons map into the brain and a cross-section of the mammalian brain, in this case it's a human brain, of how we process this much information. Computing behaves very similar to this. But if you consider how much data the brain is constantly processing, the amount of quantity you're constantly receiving, right now you don't feel that draft coming from back there, but when I call your attention to it, you probably do. What is that? That's denoising, that's filtering, that's recognition of the pattern. And quickly, we develop insight from that and we respond to that. It happens so fast for us. And our brain is mapped to all of those different workloads, we can say. So the eye, the lips, the face, the jaw, the toes, the fingers. Similarly, when you look at machine learning workloads, you're going to be looking at deluges of data, vast quantities. In the Bay Area, we have a bunch of companies that are all working on different forms of autonomous cars. Right here, the smart factory of today generates 1 petabyte of data a day. Right now, the number for autonomous vehicles, somewhere between 5 to 7 terabytes, if you're looking at the data center side of the model and the device side of the model. What are we going to do with all that data? How much of it is useful? What portions of it are necessary? So enter AI. The godfather of all analytics and AI systems is ultimately analytics. It's that classic pipe of setting up your data stores, setting up your data ingest, setting up your process, setting up your micro models, your macro models, your production systems, accelerating, offloading, and putting it into place. Deep learning gets a lot of attention, but keep in mind, we're at a machine learning conference, so make no mistake that machine learning is where you will see your system's production. So this is our point of view, Intel's point of view on what and where AI fits. We spoke a little bit, in fact, we've been speaking the entire conference about that. You're going to see it in almost every single segment of the market, and while folks say AI is a little bit scary, not sure how scary it is because we cannot process 7 petabytes of data or 7 terabytes of data for that matter a day, let alone in a minute. That's where we're lucky enough to be at a time where we have the computing power, the storage, the acceleration to be able to make that happen. So highlighted here are just some of the use cases. I'm happy to talk to almost all of you, any of you, offline about them if you're working on something specific. But we touch all of these segments at Intel. I have colleagues here also. All right, so a perspective on AI. AI definitely has a life cycle. Shri this morning was talking about how data is fluid. It moves through almost like water. And so really ultimately, while we see a lot of things in a POC environment, proof of concept environment, ultimately where you want to go to, we all strive to go to, is that organizational and structural portion of it. So steps 1 through 7 is, what are we solving for? How are we going to solve for it? Do we have the skill sets and the compute and the resources for that? Does the team that I'm working with know how to approach this data? Is it federally governed? Is it regulatorily governed? Or is it just available en masse? So really, for us, this whole life cycle is a big part of how the full AI deployment behaves. So it's part machine, part compute, part people, part process. It's all of it. It's a system. It flows. At the end of this talk, I'll be giving everyone a few URLs that you can go to, but the easiest place to start before I get any further onto the Intel side is software.intel.com. If you haven't checked out our software tools, our products, and our optimized stacks, please go there. We've done a lot as a company to acquire, broaden, and aggressively tackle AI. Also, most of you folks may not know this, but you're already doing AI every day, all day. Every time you go into your Outlook server or your email server or you're deploying something in Google Cloud, we're powering a lot of that technology already. So you're already touching the good old CPU and all of the other accelerators that we bring in a whole new modern way. But for us today, how you production an AI system is going to require data, but we also look at the solutions that you're looking to build. So we would consider H2O's AutoML or sparkling water a solution. The tool chains behind that you need to have so that you might take your model from H2O and production it perhaps into a Cloudera Hadoop environment. Who knows? There should be some interoperability there. People should have choice, data scientists should have choice, but mostly the systems that we're automating should function with each other in an ethical and responsible way. And then the hardware. So the hardware that we're working on, which is probably not the sexiest, but I'm going to give you guys one 30-second primer on hardware in just a moment. Hardware is pretty important. Hardware is so important, in fact, that if you think about what one chip, one processor consists of, 40 billion circuits on 2 by 2 millimeters. 40 billion circuits. You guys know a guy, have you heard of a guy named Babbage, the inventor of the computer, 1700s? Yeah, Charles Babbage, the computing machine. Imagine that machine on steroids. Currently, in our architecture, that is what our current processors consist of. Zeros and ones, gates, all at a subatomic level, taking the data that you're inputting, I'm inputting as a data scientist, as a model developer, all the way down, bending the laws of physics and bringing it up back to you in nanoseconds. We have 4 families of silicon. They're called field programmable gate arrays, ASICs for neural network processing. We have classic CPUs, which have graphics built in, and then we're also building discrete GPGPUs. So we have 4 families of silicon. Where all of this is headed is that we view that AI isn't just a single ingredient story. Right now, you can probably get on software.intel.com and download any of these SDKs because they're open source and they're free, and you have the x86 processor on your PC. You can do model development right there. You may actually find out that you need a tuned and optimized library for that. In particular, this is important for those of us who touch algorithms. When we consider what an algorithm is, which is the mathematical expression of processing bits and bytes in the simplest possible manner for an expression or an outcome, say a visual filter or a data filter, that's where the algorithms play into it. So we tune our algorithms to work across many different families of hardware, not just ours, because AI is generally an open source and an interoperable story. So with that, our hardware, I've laid out there our basic portfolio, which is your classic XEON, FPGA, Atoms, all of our classic families that you'll see in your HP or IBM or Apple PCs and servers. You'll see them everywhere, but it's really the tools and tool chains that will matter. Here's a couple of examples of what some stacks look like from an infrastructure standpoint for how you set up for AI as a box. Happy to talk to you about all of this, but really you can see that there's containerized views, VM views, those are cloud-style setups, and then if you're doing for a high-performance environment or a healthcare environment or a banking environment, then you tend to go into a more HPC cluster-type behavior. Again, we'll talk more about that. I have very limited time, but I want you to take away 2 things from this. One is that there's many ways to consume where your data lives, how it resides, how to structure it, standardize it, and consume it. This is something we all forget when we're doing the model development work. Am I getting the right data that I need? Is this overfitted? Is k-means the best method of doing this executable, or do I want a more simple or more complex method of choosing an algorithm? Generally, we data scientists don't pay attention to the infrastructure stack, but by and large, 97% of your data resides in the infrastructure. We have some customer testimonials. Happy to get into that. But we talk about AI, and by a show of hands here, how many of you really dislike labeling and cleansing data? By show of hands. Oh, everyone loves cleaning up garbage, huh? Okay. Why I'm saying that is in the units of time, let's say we have 10 hours to build a model, really only about 10 to 30% of that time is spent on the machine learning portion, the actual math portion of that AI function. The remainder of it is about sourcing the data, cleansing it, scaling it, and making it consumable up at the UX layer. So I want to share just a couple of examples of where we are with our work. Last night at dinner, I overheard someone say, yeah, you can't really do AI on a CPU. And I asked them, why do you say that? And they said, well, because everyone's always told me that I need something like a graphics accelerator. And I said, what does that mean to you? So this person came forward and basically clarified that they're doing matrix math. Matrix math. That is the heart and soul of what data science and machine learning is. Whether you're looking at a time series distribution or a topological distribution, the Alteryx stack used to be a GIS product once upon a time in terms of the driver and the middleware. So you could build geographical planes and structures so you can build 3D models off of it. So when you consider where and how that data is coming from, sure. In the prior slide, we talked about that 10 to 13%, 15% sometimes for your actual tuning and model training for your AI lifecycle. Maybe you need an accelerated, power-hungry system there. But for systems like H2O and for what we all do, which is production systems, you generally need to look at the full pipe. We, as a company, Intel, but most of our partners, whether you're looking at Google or Amazon or Dell or even your basic PC vendors, we're all in this race to delivering the best possible way to making your models executable in different environments. Recently, I'm just sharing a medical imaging use case with you of a customer, but basically we recently released an SDK called OpenVINO. You can download it. It's a computer vision stack. You can perform it on your CPU, on your PC. We found that with this accelerated software stack, which is firmware, filters, algorithms that are pre-trained, about 20, and then the UX portion of it, that you can get up to 200 to 400, about 200x, 150. Actually, I think the number was 158 when you look at a full carrying load of that for inference. Inference meaning moving across the production pipe. What I'm saying is AI is very much possible across many, many different environments. The question is, have we figured out what are the tool chains we're using? So as I encourage you to do, go into your open source library, go on to Git, go on to software.intel.com, go on to Stack Overflow, find out where the best, most tunable environment is, download that instance of Python, download that instance of R. It's available to you. And most of it is free. In this case, it was predictive analytics. My background's in informatics. You guys know that I was passionate and am passionate about automation in healthcare and life sciences for making better clinical decisions and medical product decisions at the end level. When I was a grad student, I actually was part of a study for Blue Cross Blue Shield, and I'll wrap up here. We found that about expert systems at that time, as they were about 96 to 98% more accurate, actually 15 to 20% more accurate than physicians that had been practicing 15 years on diagnosing an illness. I think the accuracy has gone much higher. But the point being is that we have the tools available for us. I'm going to go fast across a couple of slides because I want to just make sure that I give 30 seconds for questions. Excuse me? Oh, pardon me? Okay. So as I mentioned earlier, a couple of things, a couple of takeaways. First is analytics is the father and mother of machine learning and deep learning. Almost all of us are working at the diagnostic and predictive analytic level today, based on the technologies we have available. Some of us who are in forecasting models or population models or time series modeling, trading, that broaches on the predictive side of things, forecasting. And then ultimately, we, the data engineers and data scientists, are consuming the cognitive analytics for making long-range AI-based decisions. So I'm going to pause there and see if there's any questions. But before I leave, I gave you guys 2 pieces of homework. One is software.intel.com. Go there, download software that's interesting, useful, and easy for your PC to experiment with. And then you'll be hearing a lot more from us about H2O and Intel and our awesome partnership and what we're doing to democratize machine learning. Thanks.